there we have. So first of all, anything you want to share about the group work, or anything you were doing during the week that you want to share?
So we got a good amount done. I think it was a really rough weekend.
You were working in the translation of the battleship into offshore environment, right?
Yeah.
Because I think I got confused when I told you that you also have the group work of doing this new file-based database, you know?
Yeah.
Because this is starting today. It was not for the previous week, but for the next one. So
Oh.
I'm very sorry. Maybe I got confused about that.
Okay.
You
Yeah.
know,
We thought it was two projects due today.
No, exactly. Because the group work for each class is starting the day of the class. So today, in the class 4, we have file database. If you did something, doesn't matter. You can just continue.
Yeah. So we try to split up the work for the battleship OOP, and because we met up, I think, on Friday, and we split the project up into the necessary classes that we thought would fit, and then we went on from there. I think it was a really rough weekend for Yatri.
Yes, so I know.
Yeah, so he was initially going to do the board class, and then he just messaged me like today at like 3 p.m. He said he couldn't finish it. So I don't think the battleship's fully functioning. I mean, if you want to take a look at the code, I mean, we have a good setup.
We don't need the code working, you know. Just if you have anything to share about the decisions you made, I don't know, the data structure or something you used.
Yeah. So if you go on group 2,
you were in the group with Abdul Nasir and Yatri, right?
No, it's Doug and Yatri.
Doug. Okay. Doug and Yatri.
Yeah, I think he has some plans tonight too. It's crazy.
What about Doug? Did you manage to meet him or?
Yeah, he was gonna do the, let's say, ship class, and he did that. He just had a busy weekend too, and a busy week, so I don't think that's why he's not here.
All right.
Yeah. So I mean, I could try to talk to you.
Did he tell you something about if he's going to attend today or not?
He said most likely not. He said he's really gonna try, but I don't think. He said no promises.
News. Okay. All right. No problem. So perfect. You're, let's say, like half of the job done, or a bit more, a bit less?
I would say half. It's just because we worked on it separately for the different classes. We probably need one more chance to get together and link all of them up.
Sure.
Yeah.
Okay, perfect. If you have some time during this week, you can probably meet one more time, and while you're organizing the show for the file database, you can also join together all the parts.
Yeah, that can happen.
Perfect. What about you, Neil and Sajib? Any news on that?
We got pretty far. So Sajib and Abdul Nasir started when I couldn't make it Friday, and they kind of laid out some initial design decisions. And then I worked with Sajib one night to kind of knock out the rest of that main data structure talk, and then we finished most of it last night actually. So me and Abdul Nasir. So the attack mode works, the defend mode works.
Amazing.
We just don't have a few validation type things, like if ships are overlapping, or if you kind of like we check if ships are out of bounds, but not if you put in some kind of funky non-character things. I think the biggest question for me though is I feel like while we did use OOP, a lot of it I felt was kind of like just two big classes with a billion methods. It'd end up kind of felt a little procedural, you know?
Yes, that is really common when you start moving into offshore in the programming, because you try to do the same of procedural programming but with objects, you know? So you make one huge class and you put everything inside it. That's not the idea.
Yeah,
you have to separate the responsibility.
Yeah, so we did have we had like a mode class that kind of did a lot of the actions on ships and on the board, and then we had a ship class that would kind of generate a ship, and then the ship would have properties like coordinates, orientation, things like that. But you know, the ship classes were kind of lightweight for what they were really doing. It really felt to me like we just had tons of methods, and it felt kind of procedural. And we got caught, and oftentimes we would have methods in one of them that we needed in the other, and we were like, shit, like the ship has that method. How do we pull that out? And then I was like, some of them we copied. Then we talked about using like abstract classes if we refactored, but so we got it working, but it's not terribly on OOP, but it's not how I'd like it.
Where is the code? In Cloud9?
Yeah, you can see it.
Want to take a look?
So yeah, it's under Class 4, Group 1, Battleship OOP.
Perfect. So tomorrow I will take a look and see if I can give you some advice on the classes or design or whatever. But anyway, you know, there is no single correct way of doing this. You just have to think, take a decision, and go ahead.
Yeah.
All right.
Right.
So, and how do you feel about still working with this battleship? Are you getting tired, or is this getting interesting? I know I want to get any conclusions on the movement from procedural programming to object-oriented programming. If you notice any, I don't know, which was the experience, or is it more clear, more difficult? How did you feel?
I think since the procedure was the first assignment, we were kind of like figuring out things. I think that was more difficult. And then once in OOP, it was just like translating from that file to this file. So this went pretty smooth, I would say.
All right. Hey, Abdul Nasir, how are you?
I'm fine, man. How you doing?
All right, man. Fine. Okay. So let's start by making a quick review of the assignments, the individual assignments. Did you manage to make all of them? They were mainly about files, file managing, and also decorators. One about unit testing, I think.
Well, I did everything except 2. I think 9 and 14. That's the ones that I
Yeah, I have problems with the decorators. I still kind of don't get the idea.
All right.
Yeah,
okay. So
for me too, for me the biggest confusion on decorators was when to use the rep function versus when to use the call dunder method.
It's totally. I mean, there is no specific case for each of them. Decorator needs to return a callable object, you know, an object that can be executed, and you can either return a function that of course is a callable object, and you can return a class that implements the call __ call method. You know, it's totally the same.
But would you like to give us like an example?
Yeah, sure, of course. But let's go in order. Let's first go through file handling, and then when we finish that, we can cover decorators. And I also want today to cover a bit about modules, packages, and virtual environments. Have you ever heard about that? It's a really important topic, really important topic. So let's go to Cloud9. I've selected a couple of assignments. I think they were the most complicated ones, so we can resolve them all together here. Take a look in class 4. I have created a new file handling.py file there, and I will paste the text of the assignments. I think we discussed a bit about this with you, Neil. You remember that?
Yeah, so I didn't think this one was actually that difficult. I think it was that I didn't read the instructions clearly, and I was only returning the dictionary keys for the lines that were there rather than all the lines.
That was a bit confusing. Maybe it's not well explained in the description. I'm sorry about that, but yeah, the test case were looking for the whole dictionary with all the keys from A to Z, you know. And so if you were only including the one that appeared in the file, the tests were going to fail. That's basically the idea. But let's take just 5 or 10 minutes, and we can resolve it all together here, just to see if you did a different implementation to the one I used. Okay.
Right.
Any volunteer that want to start coding in there? Please let me check. Wait 1 second. Uh, 1 second. This is the assignment number.
Number 9, I think.
Number
Yeah,
9.
9. Okay.
Number 9. So, Will, do you want to start coding there?
Me?
Yeah.
Yeah, sure. I didn't get to this one, so.
No, it's. I know. That's the reason I selected you. So, first of all, you can explain us, like, conceptually what you're going to do.
Okay, so let's write a function. Word per
Yeah, the
line.
basic idea is that you're going to have a text file which is going to contain just one word for each line, and you have to count. You have to return a dictionary that contains the counter of the amount of words you have starting with each letter.
Okay.
Make sense?
Yep.
All right.
Okay, so first we got to open the file. So go ahead and
Right.
do that with this.
I'm sharing the screen, so Cloud9 is recording the video.
Okay. Wait. I'm actually coding on a different monitor. Okay, let me open this up on my Mac. You want me to share the screen on the Google Hangout?
What? No. I'm sharing the screen.
Oh. Okay. What is that? Okay, so we could go ahead and just do to hit every word in the, because each line is just one word.
Exactly. You have to check the first letter of the word and like increase the counter in 1 every time you find the letter.
So would this work for word in F? Would that hit every line? Then I think I read something about that.
That worked for me. If you can iterate over the file name.
Okay.
It iterates over the lines.
Exactly.
Okay. And then I mean, hold on, let's first create a dictionary. I mean a list. Wait, is it a dictionary? Okay.
It's a
Yeah,
dictionary.
actually a dictionary.
I'll just make an empty one for now.
Yeah. Okay.
And you need a counter, right?
Yeah.
Yes, actually, we should at the beginning start the dictionary with an empty counter or a counter in 0 for each single letter, right?
Yeah.
Somehow. Do you imagine or picture any way of doing that?
Not off the top of my head.
Anyone that can help here?
Can you repeat what you said? Like a counter within a dictionary?
Exactly. We have to build this. If you check my screen or my selection here, we have to build this dictionary. The letter and the counter in zero for each of the letters.
So would you just like hard code every single letter?
No.
Okay.
Try to not hard code all the letters. We need to do that programmatically somehow.
So how would you, like, I don't mind, I don't know. Okay.
I've got a question. I couldn't find it. Does does Python have an iterator that'll go through characters, or do you have to do it?
Yes. I was just about to say that.
So I couldn't find that one. I use like Ord and char.
Yeah.
But
I checked your code and yeah, I saw that. But there is a more interesting way that is importing one module. It's called string.
Yeah, string. Okay.
Yeah, and you can do something like string.ascii lowercase, I think.
And then
you are going to.
It's that from keys.
Let's try this. Let me comment out all this just to try what this is returning. I'm going to execute counter by letter here, and I'm sending. Oh, okay.
And that should give all of them, right? It's like A through Z.
This is a file out that we have to create, of course, but for now I'm going to execute just this to see what this ASCII lowercase is returning.
Okay.
Do you see my screen? There is the whole list of letters. It returns a string that contains a whole list of letters.
Yeah.
So what we can do somehow is a dictionary comprehension using this and initialize all the letters with a counter in 0. Do you remember something about dictionary comprehension? Pretty hard. Anyone else that can help here? I want to make a dictionary comprehension using this to initialize the dictionary.
Roughly. Oh, I know what it is.
Do you want me to help you?
Let me see if I can try it.
Okay. Very nice.
Okay, so is this something like? I don't remember like the first the things to put in here, so let me just go ahead with the for loop for I in range. Is it 27, right? I don't know. And so let me see, ASCII, right? So
Wait, in this case, which is the iterator? Do you remember that in every comprehension you need an iterator, and then you're going to perform some action on each element of the operator? In this case, the iterator is ASCII lowercase. There is a string, but you can, of course, you know that a string can be iterated letter by letter, position by position. So you can use that as the iterator, and you're just using each letter.
Okay, so instead of using like range,
exactly.
Use that. Okay, so all right. I think that's good. So the key from a value in.
Yes, as it is a string, you're not going to have a key and a value. You're just going to have a letter. You know, for letter in string dot.
Oh, this one. Oh yeah. So, but how do I get the? Okay, let me just use the letter. So for value.
Exactly. For value in string ASCII lowercase.
ASCII lowercase, right?
Perfect. And then you have to do something like B semicolon 0.
Yeah, V semicolon 0. But so all of them will start with 0.
Yeah, exactly, because we are just initializing the dictionary. You know, we want to have the whole dictionary, but all the counters in 0.
Right.
Make sense?
So is this correct? Because it seems like there's still.
Yeah, it looks totally fine to me.
Oh, okay.
What do you think, guys? Makes sense?
Oh, yeah.
Looks good.
So we have this as the iterator for each of the characters we find in this string, we're going to put a key in the dictionary with the counter in 0. Let's replace this with key or letter.
Okay.
Letter. So something like this. Let's now print the dictionary to see how it looks. Wait a second. And there we have. I don't know if you see. Am I sharing the screen? No. Share. There you have. You see the whole dictionary with the letters and the counter in 0 here. So that's exactly what we need, because now we can start iterating through all the lines in the file, and we just have to add 1 to the letter we find in the first position of the word. Make sense? Make sense?
Yeah.
Do you want to continue now?
Yeah.
Now you have the dictionary, you just have to iterate through all the words and get the first character or letter in the word and add 1 to the counter of that letter.
Okay. So for word in S, we could just do...
Exactly. Plus equals 1. Perfect. Perfect.
And that would do it, right? That'd
yeah, I'm going to create a test file here. New file, test.txt. I'm going to put a couple of test words like hello, bye. There you have some testing words. Okay, and now we can execute this, and this should exactly return the dictionary. Perfect. Let's see if this works. Okay, we're not printing anything, so I have to print the result of the function. See, it returns. Print again. And there we have. Okay, we have one letter starting with C. Let's see. Yeah, of course. We have what else? What else? 2 letters with 2 words with P. Yeah, Python and print. It's working perfectly. Okay. So, make sense?
Yep.
Any question on this? Nothing?
Nope.
All right. So, take a look at my screen. I'm going to show you this quickly. I have some slides here. This is nothing new. I'm sure you already know this, but just as a conclusion, we always use this built-in open function for file handling. This is going to return us a file manager, a file object that allows us to do any operations we want with the file. We have, of course, we have to specify the file name here and also an access mode. Do you know that we have different types of access mode? Have you read about that?
Yeah.
So in this case, we just use the mode read. That is the default one. If you're not specifying any access mode, you are going to open the file in a read mode. That means that you cannot modify the content of the file. You can just read the content. You also have the W, that means write. This can be a bit dangerous because when you open a file with the W, with the write access mode, you're going to erase all the content on the file. So if you have something in there and you open the file with write access mode, you are going to lose everything. Okay? And in the other hand, we have the append. That is in the case you have a file with something inside and you want to add or append some content to it, you can open it with the letter A. That means append, and you can just keep editing the file. And we also have this read and write. There is a combination of the previous one. This is basically the interface we were using. When you execute this built-in open, you're getting an object, this file handler or file manager object. You can read lines, you can read the whole content of the file, you can iterate through all the lines. I'm going quickly through these topics because I'm sure you have already read about this. Okay, if you have any questions, just stop me. You know, when you are iterating through all the lines in the file, you have like a pointer that is pointing to the current line you are reading. And if you want to know the position of the pointer, you can use this .tel function. You're going to have a number that is the position where the pointer is currently located. Where else you can seek that pointer, move the pointer to position 0 or to the line 3, 4, wherever you want. Suppose if you open a file and you iterate through all the lines, you're going to have the pointer in the last line of the file. But if you want to iterate through it again, you have to seek the pointer again to the position number 0, and you can start iterating again all the lines. Make sense?
Mm-hmm.
Yep.
Okay. And an important thing, you also have the close file. If you don't close the file, you're going to have an open pointer to the file all the time, even though you finish your program. Some variables might be there in memory pointing to the file until the garbage collector is collecting them. But for this particular reason is that it's very important to use context managers with files. Have you ever heard about context managers? Never? I know you have used them. Actually, Will, when you implemented the code recently, you have used a with in there. You know?
Yeah.
Oh,
So that's basically, yeah, that's basically called a context manager. And I'm going to go through it now. This, right? This is a syntax you used in there, using the with. And I'm going to jump to the other slides about the context managers. This is the general goal of a context manager. The idea is that sometimes you need to perform some operations before the behavior of your functions or code, and some operation at the end or after the execution of your code. You know, some preparation and some cleanup tasks for some reason. In the example of the file handling, we have, first of all, we need to open the file. And at the end, no matter what is happening in the middle, we need to close the file to avoid having these pending pointers in memory to the files, right? Make sense?
Yep.
And we don't want to avoid closing the file, even if we get an error in the middle or something, an exception or wherever. If the code breaks somehow, we still want to close the file, no matter what. And this is why we have this context manager concept. Everything that implements this interface with the enter and exit method is called a context manager. And it's pretty simple. The enter method is executed before the code that you have in the with block, and the exit code is executed after the code you have in the with block. So take a look at this example. We have just a print in the enter that says starting, and a print in the exit method that says done. And in the with block, we are just printing a hello world. And if you check the output of the execution, you will see that first of all is the enter method is executed. We have the print here. Then the actual code of the with block. This is the main functionality that we're implementing. And after that, the exit method is executed. Make sense?
Yeah.
Pretty simple. But this is really handy when you are using, as an example, file managing, because all the opening and closing files are already implemented out of the box for you. And this is the most interesting part. Suppose that we have the same context manager, but we force to raise an exception in here. The important thing is that both the enter and the exit, both of them, are executed even though the code is raising an exception. Right? So this is super important. So because, for example, if you're here opening a file with the as a context manager, something like with open file name, wherever, and here you do something that breaks the code or writes an exception, the file is going to be closed anyway. This is very important. To be honest, I've been working like 4 or 5 years with Python, and I've never implemented a context manager myself, but we use them a lot. You know, this with statement, every time you use the with, you are using a context manager. Just want to tell you that. And this is the interface. If you take a look at the code, the source code of the project you are using, or the object you are using here, for sure you are going to find somewhere this interface containing the enter and the exit method. Make sense?
Yeah.
All right. Just as a quick introduction to context managers. Okay. Let's do. I'm going to keep this, and I'm going to create a new file. I want to make a second example of file handling in Cloud9 because it was like a complicated assignment that mainly none of you could resolve, or I think a few of you. So I will create a new file in the class for new file handling 2.py, and I need a volunteer that can help me with this assignment. I think it's the last one. Is sort line in a text file. Do you remember that?
Yeah, I mean, I finished it. I can help, or someone else wants to do it. That's fine.
All right.
I was able to do it after.
All right. Let me see. I'm just gonna pull mine up so I have reference to it.
So do you see the description there in file handling 2.py?
Okay. Just wait. Let's see. Okay, we got it now. All right, so the basic idea here is that we want to read a file, get all the lines from that file, and then sort them either ascending or descending, and then write it back to that file.
Perfect. So we're basically modifying the original file.
Right. So we'll start by reading the file. I think that's pretty straightforward. And so you could do this 2 ways, I guess. I guess you could open it as a read-only file and then write back to it in a separate open mode.
Yes.
The way I did it, I opened it as read plus write, and then I kind of just edited the file in line. So you could probably do this a couple different ways.
Perfect. Perfect.
So I start by opening the file. So actually, there's 2 cases here. So one is if sorting equals and then the other is send. So we'll just do the ascending one first. So if we open the file, I guess there's 2 ways you can get all of the lines. One is that you can iterate for each line. Oops, that's file. So in the past we were using just f dot. You could do f dot read line or like for f or for line in f, and you can get each line.
Yes.
But I did see that it looks like it's actually more of a deprecated function, but you can just use read lines.
Yeah.
And that will actually grab all of it at once and put it into a list. So
did you say it's deprecated function? What?
I don't know if it's actually. I don't think it's deprecated. I think they just said that. I read somewhere online that it's kind of like an older function, and they kept it more for backwards compatibility. But
yeah, well, actually, the problem I also use that read lines, but you have the problem with performance, because you are reading the whole content of the file in memory, and you are storing the whole content in a variable. In this case, there is no problem because we are just using test files that are pretty small. But imagine that you have, I don't know, 3 terabytes file, and you do this. You need a ton of memory to store the variable in there.
Exactly. It's going to pull everything into memory at once, so you can't stream it. So what I did is I just set line list to read lines. So that gives you the list right away. I tried to sort this in line, but when I used sort on this, it wouldn't chain like that for whatever reason. So I had to do.
Read lines, in this case, line list is just a list with strings that each string is a line in the file.
Right.
Perfect.
Right. So this is basically like line 1, line 2, line 3.
Exactly. Being all the line strings.
Right. So then for this one, for ascending, you can just do line lists dot sort. It defaults to ascending. I was pounding my head against the table because I was trying to do like sorted equals that, and then I realized that this doesn't return the sorted list; it sorts in place.
Yes, it's a mutable method.
Right. So I forgot that, so I had to fix that. So that's now the sorted list. So now we kind of have what we need, but we need to put it back in the file. So you could open another file here and do it as just a write. And then I found a few different ways. One was you can do like f.truncate, and that clears a file, but I think that doesn't work while the file's open.
That was new for me. I've never used it, truncate.
Yeah, it's just something I found Googling around. So instead, I used f.seek, which...
Yeah, you're moving the pointer to the first position in the file.
Yeah, and that resets that pointer to the top. So then once you're at the top, you can do just kind of the inverse of this read lines and do f.write lines, and then line list.
Yeah.
So that's that, and then really
and you're pending. I mean, the second sorting way is pending, right? Because you have an if. Okay. You are doing the same. All right.
And this was sort, I think, reverse equals true. So this is basically the same thing. I guess looking at this, I probably should pull out the... I guess I could pull out the file, and I could do it a different sort, so I'm not kind of reusing code here. But this should work as it is, I think.
Let's see. We can try it out. I'm going to execute this code. I think we have some indentation issues here.
Yeah, I think my tab is not giving it 4 spaces for some reason. I don't know.
You have 2 spaces. Yeah, it should be 4, and you are using 2, I think.
You could change that on the bottom right.
Yeah, it's normally defaults to that. I don't know why it's switched to 2 for me on this one.
So let me run the code and see what is happening. I'm using the same test.txt file. So let's see if by default we are using ascending, right? Yes. So running the code. Oh, error. Indentation error. There you have. I think it's with this. Oh.
That not in.
Oh, okay, yeah, sure. Here in the if statement, we have an indentation error. All this needs to be indentated.
Oh, yeah.
There we have.
Okay. There we go.
No, the elif needs to be in the same line that the if.
Yeah, you're right. I don't know how to...
There you have. And I'm going to execute it again. So invalid syntax. We're planning a semicolon here. Okay.
Oh, I missed it on the elif.
Yeah, exactly. And it's done. Let's see if it is sorted. Yeah, it worked, I think. By course, hello, Martin, print. Perfect. And I will execute the same, but sending the sorting equals to descending. Something like this. There you have error. There's a problem. We are using here the f variable in the elif, but it's not defined because we are opening the file in the other branch of the if.
Oh, yeah, I guess I meant to reopen it again.
No, what we can do is
put it at the top.
Yeah, exactly. We don't need to have the whole code inside the if or elif, because we just need to make the differentiation when you are sorting the list.
Right.
Exactly. So you open the file, you do everything else, and before sorting, you check if it is ascending or descending.
Right. So we can do that, and then down here we would need to reopen the file, though, right, and close it.
Why?
Does this?
You can do everything inside the with block.
So I have to indent this then, right?
Mm-hmm. Perfect.
So I think that should do it.
So let me check. We have again indentation problem here.
Right.
If sorting is ascending.
Change my indent.
Yeah, we don't need to seek 2 times.
Yep.
We can do this out of the elif. Something like this.
Yeah, right.
And we don't need to write 2 times.
Yep, and that can go. It's just the sort, really. And this can go to line.
Don't need this again. Sort or sort reverse. And then we seek to the first position and we write.
Mm-hmm.
Oh.
You can get rid of it, yeah.
There you have. Something like that, right?
Mm-hmm.
And we're using the if block just for 1 line. Let's see if it is working. Done. And checking, yeah, perfect. Oh, wait, we have 1 error here. Somehow the word something and rmotr went like concatenated. I will try moving this like this and just mixing them to try it again. Running the code again. Perfect. Yeah, it's working.
Yep.
Very nice.
So what's the difference between like sorted and sort?
What?
What's the difference between sorted and sort? Because I used, I think, sorted.
The built-in function sorted. This one.
Yes.
Yeah, I think they are two. This is like a method of the list object, and the other one is a built-in function. But they are doing basically the same.
Oh, okay. Because I used them instead, yeah.
That's totally fine. They are working pretty much in the same way.
Okay.
So, any further question on this? Or in the topic of file handling in general, do you have any questions?
Like, how do you seek to the end of the file? Like, end
What?
UOF?
UF? Didn't get it.
End of file?
Ah, right. So actually, you don't need to check the end of the file, because if you iterate through all the lists using a for, for line in F, for example, the end of file error or exception is going to be handled automatically for you. You're going to iterate through all the lists until it gets to the end of file. Make sense? You don't need to care about the end of file exception. Was that the question?
Yeah, and I also wanted to know, like, how do you seek it to the last position? Like, if I say fseek -1 or something, can I go to the last position?
Well, actually, all the times I needed to do that, I just calculate the length of the list. You know, when you do the read lines, you get a list. You just calculate the length of the list, and you do seek and the length of the list. There should be another way. Not sure about that, to be honest. But no, you cannot use negative index on that.
Okay.
You can't do that. Okay. So if there are no more questions on this, we can move forward. Right?
Yep.
So close this, and let's make a quick introduction to the topic of decorators. I'm going to share the screen again. We have too many things to cover today. Decorators, do you see the slides there?
Yeah.
So you told me that it was kind of hard to conceptually understand what decorators are doing, or which is the goal behind decorators, right?
Yeah. So hold on.
It was more the technical part of how to write a decorator, or more conceptually when to use it, how to use it.
I think just when to use it. Is this just when you want to alter a function?
Exactly. So take a look at the slides. We have this general goal for a decorator. This is like the official description for a decorator. Inject or modify code in functions or classes. This is really important. You can decorate a function or a class wherever you want, or a function inside a class that is a method, right? You can decorate pretty much everything you want in Python. The thing is that you have these rules. Every single decorator is going to receive a function or a class, I mean the object that is being decorated, as an argument, as a parameter, right? This is related to the topic that we have covered before, that is functions or classes as first citizens in Python. You can do with a function or with a class, or with a class, pretty much the same that you can do with everything else in Python. So you can send a function as a parameter, assign a function to variable, I don't know, anything you want, you can do that with functions. So the decorator is receiving as an argument a function, the function that is being decorated, and it needs to return a callable object. Again, a callable object is not only a function. Of course, a function is a callable object because it can be executed, but you can define a custom class that implements the __ call method, and that is also a callable object. But let's first cover a basic example, just to understand conceptually what we are talking about. Take a look at this. We have this sum function that is printing the sum of the two arguments that is receiving, right? And we want to implement this decorator. It's like a validator, you know. I want to receive integer arguments, and for that we are decorating the function with this only int arguments function. Take a look here. Inside the decorator, first of all, we are receiving, am I sharing the screen? Yeah, right? Yeah. First of all, we are receiving as an argument the function that is being decorated. In this case, the sum function. Make sense? Sum function is being sent as an argument in here with the letter F. Did you get that part?
Yeah.
All right. So here inside the decorator, we have the original function, this sum function, and we can do with it pretty much whatever we want. We can alter the function, execute the function, return the same function, return a new function, wherever, the only condition here is that we need to return a callable object. And this, we usually define a new function in here, inside the decorator, that somehow make some new logic on top of on the original one, and then returns this new function that we are creating. So this function is being sent as the argument. We find the new function, we do wherever we need in here, and we return the new function that we are here creating. Next one. Take a look at this. Remember, the name of the decorator is only integer arguments. And for that, inside the new function, it's like we are wrapping the original function in this new function in here, and we're adding some custom or new logic to it, right? So for that, we're checking if A or B, that are the same arguments that we're getting in the original function, we're checking if any of those are not integer values. If we get a non-integer values, we're writing an exception. And if not, we're just executing the original function. All right? Take a look at this. This line here is the same as doing sum A, comma B, right? Because f, in this case, is the function sum that is being decorated. Make sense so far?
Yeah.
All right. Or no? Do you have any questions? Please stop me if you don't get anything, because this can be a confusing topic.
Okay, so the function within the wrapper function, right?
The wrapper function is the new f, right?
Yeah, new f, right? So can new f be have like multiple arguments, like more than just this two?
Yeah, usually the wrapper function, this one, is receiving exactly the same arguments that we are receiving here.
Okay.
Yeah.
Right. But
because when this, as we are returning this, actually, instead of executing this sum function, we are going to execute the new function. So we need to support exactly the same arguments that the original one, right?
Exactly. The only thing was that in the assignment, I think, where we have def new f, it was like a tuple and a dictionary. So it received a tuple.
I don't remember. I don't remember. We can go through the assignment later.
Okay. Yeah.
Please repeat me the question later when we're on the assignment.
Okay. All right. No problem.
Any further question on this? Make sense? This wrapper function around the original one, the sum function here?
Yes.
Again, decorators is a topic that you are not going to implement all the days, you know? You're probably using decorators all the time, but it's not pretty common to implement custom decorators. They are really used in open source projects, and that's the reason you're going to use them a lot, but it's not pretty common to implement them. But of course, when you use decorators, it's handy to know what is happening behind this thing, you know?
Mm-hmm.
So, but take a look at this. I've said that the decorator needs to return a callable object, not only functions. And for that, we can do exactly the same in this way. We have the same decorator, but instead of being a function, it is a class, right? And the class needs to implement this interface, the __ call function. This converts the object in a callable object. You see the comment in here? If the class implements the call method, it can be named as a callable object. This would be the wrapper function, the call one. And here inside, we are doing pretty much the same that we were doing before. Make sense? And at the end, we're just, again, executing the original function. So, again, you can use a function or a class as a decorator, but remember that if you're using a class, you need to implement the call method. All right, so let's jump to Cloud9 and we can go through any assignment all together to see if you have any questions. Up to this point, anything you want to share? Anything you want to question or something? Sure. It's a problematic topic, certainly, decorators. I don't know if you really got it or you don't want to ask anything.
So like to recap, in the first case, you have to create your own wrap function.
Yeah, exactly.
So pass. And then the second case.
Remember that the idea of the decorator is to somehow edit the original functionality of the function that you are decorating. And for that, you are like wrapping the original function into a new callable object or function, and you are adding any extra validation or behavior or whatever you want to do in there. And for that, you need to somehow wrap the function because you need to call the original one again at the end. That's the reason.
Roughly understand it. Yeah, I think seeing it more in use, will help too. But I have the general idea.
Okay. So let me create a new file in Cloud9. New file, decorators.py. And I'm going to copy this small arguments decorator. There you have. So Neil, do you want to help me? Oh, you were working before. Sorry. Abdul Nasir, do you want to do that?
Yeah, okay, yeah. It was actually the one I was talking about. So.
Yeah, perfect. So you can ask me in the code.
Yeah, so right
so
here.
You have the general interface there. You have the sum function, and you have also a decorator called small arguments that in this case is a function, right?
Right.
And we are receiving, do you remember in the slides that we were using an F here?
Yeah, now
I use the name original functions just to be pretty explicit that this one is the original function that we are decorating. So zoom.
All right. So how I solved it was I defined, the wrapper function, right? Called func. And right here, what I found online was that you're passing a tuple, but from your example.
Okay. Yeah, I know.
Right. So from your example, it seems like I could just pass like something like A, B right here, right? And that, you think that will work? It's gonna work?
Yeah, it's going to work because we are supporting the same arguments in the original list.
Okay,
so
then
if somehow in the original list we do remember the topic about like how did we call this? Like variable length of arguments.
Yeah, arguments, right.
Something like this.
Right.
Args. We would need to also support this, the list arguments and also the dictionary arguments.
Right.
And in that case, we would have to also append here these two guys. So something right? But for now we don't need them. We just need to support A and B.
Okay. All right. So next, we need to get a result. So a result that after we calculate the sum function, which is the same right there, we just the original function, right?
Exactly. So you are calling the original function with the same argument,
right?
And you are saving the result in this variable.
In that variable, exactly. How does this happen? Right, and then now we want to format it to give us what did they ask for?
No, that was another one. This is
that was
yeah, that was the other assignment. We just want to check that the arguments are lower. No.
Yeah.
If any of the arguments are greater than, that they are lower than 10. So A and B needs to be lower than 10, and if not, you need to write a value error exception.
Yeah, if the first, oh, okay, so if one of the values is greater, right?
Exactly. Right.
Right. So, well, basically, so I actually don't need. I don't think I did it this way. I think I used the max function. So, uh, so if max is max what did I say? Is greater than 10, right?
Yes.
Greater than 10. What do we do? If max, if it's not, if it's greater than 10, then we raise the value error, right?
Perfect. Raise
So
value error.
raise value error. Right. Now, else, we just return the function, right? So basically, I
Right.
just raise value function else. Do I need to put else? But, um, same function, which is original function. That's an AB.
Yeah. Right. You need to send
Yeah, I
the
need to pass
AB
in the
parameters.
AB, right? Yeah,
Mhm.
so I think that should work, actually.
Yeah, and you are forgetting something.
Oh, let me see. Uh, so
You need
I
you
need
need
to
to
return the function,
return
right?
this. Yeah. Right.
Full function, right? So, okay, so
Return func.
exactly.
Perfect. Perfect. Very nice.
Func, do I need to, yeah, I need to pass in AB as well, right? Yes. Do I need to pass in the values or I could just leave it by itself?
No, you need to return just the wrapping function. You don't need to execute it.
Exactly.
Perfect. So I
So
have
what?
added the test line here on the bottom, and I will run the code just to see if it is working well.
Yeah, but the raises value error. Let me see. Oh, I'm saying raises, sorry. Instead
Yeah,
of
right.
raise value. So,
Perfect.
right.
Running the code again. Yeah, we have a 4, and if we change this to 13, it should raise the exception.
It should raise them. Yeah.
Yep, perfect. It's working.
So that's it.
So, makes sense? Neil, I'm not sure about you. I'm seeing you like thinking a lot about this.
Yeah, I think I'm okay with it.
I want to show you a real example of using a decorator. There are a lot of examples, but this is a pretty one. This is a pretty interesting one because uh, it's also related with the topic of unit testing that we didn't cover yet. But look at this. Do you see this freeze time decorator?
Raise time.
Yeah. So this is a custom package, an external third-party library that's called FreezeGun. It's really handy when you are testing your code and you are depending somehow on datetimes, then you want to test, for example, that if you call one function, it will perform some operation for some particular date. When you do that in a test case, sometimes it's complicated because if you execute the code, the test today is going to pass, but maybe tomorrow that you're going to have a different date, the test is going to fail, right? And for that, we are using this FreezeGun library that is like freeze the time, Every time you use a datetime object inside, you're going to get always the same date, the one you specified in here. So somehow we're wrapping the test right here with this decorator, and every time you you execute or use a datetime object, you are going to have this date always. Make sense? Do you see how can we use a decorator for this particular case?
Yeah.
Yeah.
And look at this. We're doing the same for test suites. and for classes. You can decorate both a function or a class. It's the same. Like this, you have a lot of examples. So, for example, in Django, you know, the web framework for Python, you have login required decorator. It's also really useful one. Let me check if you see an example there. So this one, you see this? Suppose that you want to access a web page, and that web page needs authentication. You need to be logged in. And for that, you can use this login required decorator. And if the user is not logged in, when accessing this page, it's going to be redirected to the login form. Just that, just out of the box, using only this line. You see?
Yeah, that's cool.
So yeah, you have a lot of logic already implemented, and sometimes they are using decorators for that. They are pretty handy. Again, it's you're probably not writing your own decorators a lot. You're not going to use them from, I mean, while coding, but you are going to import a lot of decorators from third-party libraries, and you're going to use them a lot. I just wanted to let you know what is happening behind the scene, you know, how the decorator works, with which limitations you have, and which conditions you need to follow if you want to write one. Make sense?
Yeah.
So, any questions? Anything else you want to share? If not, we can keep moving. We have still 2 or 3 topics to cover.
I think we're good.
All right. So let me close this. Okay. Now we're going to move to the modules and package topic. That maybe it's pretty easy for you. I don't know if you're accustomed to it, but I just want to be sure. I'm going to show you a couple of slides. Do you see this?
Yeah.
Okay. As you may know, you are not going to write all your Python code in just one file, right? You're going to split out the code into different files that in Python we call modules. If a file ends with the .py extension, we call it a module, Python module. Of course, you are not going to write everything in just one module, and you're going to split your code in different files. You also need to organize your files, because you are not going to have all your modules in just one directory, and that we use packages. So a module in Python is just a file with the .py extension, and a package is just a collection of many modules. Make sense? Pretty simple. So suppose we have this calculator code here. We have a lot of different functions, small functions, but all mixed together in the same file or the same structure, right? First of all, we can start, for example, by dividing them conceptually by what they are doing. So in this case, for example, we have all the operations: add, subtract, square, multiply. We separate the operations into a new module called operations.py, for example. This is just an example. And finally, we can move everything else also into a new interface.py module and a system.py module. Finally, we get these 3 modules with the different functions in there. The question is how we can use the functionality that we have in a different module from the module that we are currently working on. This is the question. How can we use the different functions? And for that, we use, of course, the imports, right? Are you familiar with imports? Have you used them a lot, or? just a few times.
Sure.
Yeah, I'm pretty familiar.
So every time you need to use some functionality that is not in the current module, you are going to use this import keyword. Even if the functionality is in other module that is your own module, or if it's a third-party library or something, right? We have different ways of importing. We can just import the whole module like this. We can import one specific function or class or object or variable or whatever we want for inside a module. In this case, we have the operations module, and we are importing just the subtract function, not everything else, okay? We can also do this from the operations module, import asterisk. That means everything that will import the add, the subtract, all the methods that we have inside are going to be imported into the current module. Do you picture any disadvantage on this, on importing everything?
Like size of the executable becomes more, I guess.
Which one? I think I didn't understand.
Now the size of this module or the executable becomes
right. Okay, yeah.
bigger.
That might be one of the disadvantages. Anything else?
Could you possibly get overlap in method names from?
Right, exactly. That is really important. Imagine that you are going to import things from modules that you didn't write. Someone else wrote the code. So most of the time you don't know what you don't check the source code, and you don't know what you have in the whole module. And for that you have to be really carefully, because if you do this, for example, you're importing everything from the module, and suppose that you have in your own module you have a variable called var1, and if the other guy that wrote the code of the operation module also used a global var1 variable, and you import everything from the module, you're going to overwrite your variable. Make sense?
Are there like namespaces in Python to avoid that, or?
Yeah, exactly. But for that you have to, the way of using namespaces in Python is just importing in the proper way.
Right.
So for that, as a convention or a good practice in Python, try to not import everything. We're going to see also that there is a way to specify what everything means. Suppose that you are writing your own module, and you want to somehow hide or keep isolated a couple of functions. So when some people is using this asterisk, the function is not imported, you can do that. Have you ever heard about the __ all variable, like a special one? Do you see my screen?
Yeah.
This one, if you want, for example, if we have this module, decorator.py, and we want to define this all variable, there is a list of things that are going to be imported when the asterisk is used. So in this case, we can use, for example, small arguments in here. And when any other person perform this from decorators import asterisk, the only thing that is going to be importing is this one, the small arguments. Make sense?
Yeah.
If I remove this and I leave here an empty list, the guy that is importing everything from the decorator is actually importing nothing.
And so that's a white list. Is there a opposite one that's like a black list that like prevents?
Yeah, if you avoid defining this variable here, you're going to import everything defined globally in this module.
I guess I was asking, like, if you want to prevent someone, like if you want them to import everything except small arguments, is there something like that?
No idea. I know.
Okay.
Did you find anything?
We
can check that later. I don't really use this variable a lot because I I have the, I mean, I try to not import everything from modules. If I want to do this, I just use the from Decorators import small elements, and that's it. But in case you want to use that, you can limit the things that are being imported using this all variable. Okay?
Yeah.
Yeah.
All right. So, and then we have the concept of a package. As I said before, a package is in Python is just a folder that contains a special file that is called init.py. I'm sure you have already seen a file like this before. Do you know what this is used for? I mean, when this file is executed, or what should you put in there?
I think if you want to exclude a module that you don't want other modules to import, do you put in that init? It's some sort of...
Yeah, actually, this init.py is just another Python module. It's just it behaves the same way that any other Python module. You can do whatever you want with it. You can even execute this file if you want. The thing is, first of all, if you create a folder and you put a lot of modules, Python modules inside, the folder is not going to be a package until you create this file. Right? So this file is the thing that converts a folder into a Python package. Make sense?
Yep.
Yeah, makes sense.
Perfect. And another important thing is that all the content that you have inside this file is going to be executed each time that you import something from inside the package. So for example, if you have a package that is called calculator, and you have the operations module inside, if you do from calculator.operations import subtract, for example, this init.py file is executed. Did you know that?
No, but it's good.
That's really important. Yeah, it's useful to know because sometimes you want to do something. For example, usually, for example, if you have a package and you can also do from package import asterisk, you know? And in the same way you are importing everything from a module, you can import everything from a package. And if you want to define the all variable for a package, you can do that inside the init method of the package.
Okay.
So all the code inside the init file is going to be executed each time you import anything from the package. Make sense?
Yeah.
All right. What else? So we have, again, different ways of importing things. We can import directly a module from a package. We can, what else? We can import just one single function that is contained inside a module, inside the package. Or, again, the asterisk again, right? We can import everything from the module that is inside the package. So pretty much straightforward this. I don't know if you have any question. I would like to spend some minutes explaining something about virtual environments. Have you ever heard about that?
I mean, yeah, the concept. Not building it though.
Well, you should, if you start working with Python, you should or you must get accustomed to them as soon as possible. They are really handy, and this is actually something that we use every single day at work. Virtualenvs is like a must know. So let's take a moment and do you see my terminal here?
Yep.
Yeah.
Okay. So you know the pip Python, the pip is the package manager in Python. it's the tool you use to install or remove packages, Python packages from your computer, right? Have you ever used that?
Yep.
I think so, yeah.
All right. The thing is that you are going to have this situation sometime. Suppose that you want to run more than one project in your computer or your server or whatever thing you want to use as an example. If you want to run more than one Python project and they have different dependencies, I mean, they use different external libraries, or they use the same library but different versions. This is very important. Suppose that you are doing one project for your job and you are using you're doing one different project for your personal website or something. In both of them, you are using Django as a web framework, but in one you use Django 1.8 and in the other one you use Django 1.7. Right? You see the problem there? You can't have both of them installed in the same computer at the same time unless you use a virtual environment. Do you follow me?
Yes.
So, for example, if you want to list all the packages that you have installed globally in your machine, you can do, for example, by pip list or pip freeze, any of these two commands, and you're going to get the whole list of packages that you have installed in your computer, right? This means, for example, well, actually, Virtualenv is a Python package. I have globally installed the Virtualenv library. In this particular case, we have the version 1.11.6, right? This is what I have globally. But now we have the concept of the Virtualenv. I have the official documentation here. And this is really handy because you can install different versions of the same package in an isolated environment that we call virtual environment. And for that, we can just create using the virtual env package. We can just create, for example, env1. And this is just creating a new folder called env1. In a low level, a virtual environment is just a directory. It's a new directory where all the packages are going to be installed isolated from the global ones. Make sense? Yeah. So if I make a list of the new directory that has just been created, I have here the bin, the include and libraries directory, where I can find the executable files of Python and also for all the libraries I'm going to start. The thing is that if I do, for example, Python here, I'm not inside the Virtualenv at the moment, right? I'm just using Python globally now. If I use Python here, I have the Python version 2.7 here. And if you take a look at this special variable, I will import this package sys. And you have this special variable. Oh wait, I'm going to use IPython. That is much prettier. IPython. Import sys.path. Take a look at this big list of directories. When you try to import a package or a module from in Python, the interpreter is going to go through this whole list in order, right? And it's going to look for the package you are trying to find. So, for example, when you do import requests, this is a third-party library in Python. What the interpreter is going to do is, first of all, take a look in the current directory to see if we have a package called requests. If not, it's going to move to this user local bin directory. searching for the same package. If not, it's going to move to the next one, and the next one, and the next one. If it finds the package in any of this directory, it's going to import it without any problem. If not, if it reached the end of the list and it couldn't find the package, it's going to raise an import error exception, right? Make sense?
Yep.
Any question so far? The thing is that when we are using a virtual environment, this syspath is going to change because the path is not going to be the one defined globally, but instead it's going to be the one inside the virtual environment. Let's take a look at that. First of all, remember that I have created this new env1 environment. We have to activate the virtual environment. For that, we use the source env1, that is the directory, bin activate. We just execute this, and take a look at this. My own shell is showing me the current environment or virtual environment where I'm working, right? And I'm going to now pip list again, or pip freeze again the packages that I have. Look at this. I have almost nothing, right? Do you remember the whole list before?
Mm-hmm.
Yeah.
That means that now that we are inside the environment, we only have available the packages that are installed here in the environment and not everything else that we have globally. Make sense?
Yep.
For example, if I want to install something here, I just have to do pip install IPython, for example. That was a package that we were using before. Downloading the code. And 1 second. There you have. Now this installing. Perfect. And if we repeat the pip freeze, now we should see the IPython there and also the dependencies. You see that this library also was included here because for sure it is a dependency on this IPython package. So the pip is not only installing the package but also the dependencies. This is really important. It is similar like the apt-get in Linux, if you are familiar with it. Pretty similar, but for Python packages. So now that we have the IPython installed in the virtualenv, we can execute it. And if you take a look at the sys variable, sys.path, look at this. It is looking in first place inside the environment. Do you see this?
Yep.
Yeah.
So if I try, for example, to import Django, I'm going to import error because I don't have the Django package installed in this virtualenv. Make sense?
Yep.
Yeah.
All right. Do you have any question on this?
Nope.
It's a really important topic. If you have some time during the week, try to try it out and play with it, because if you want to start working with Python really, like in the industry, you need to be accustomed to virtual environment. It's really handy too. And I have also something to recommend. There is a Virtualenv wrapper. It's like a layer on top of virtual environments that adds like really useful tools that makes your life easier when working with virtual environments. I think I will deactivate this virtual environment. This is the way that we exit from the environment, right? And for example, I'm going to do you remember that previously to create a new environment, I used this virtualenv command with the name of the environment, right? I have globally installed Virtualenv wrapper here. You see the package. To be honest, I never use Virtualenv alone. I use always the Virtualenv wrapper. That's pretty handy, pretty useful. And you have tools, for example, like make Virtualenv. This is a command that it's going to create for example, env2, and you can specify, for example, with -a the path of your project. For example, I don't know, /home/ my name, no, /users, I'm on Mac, / my name. This is going to create an environment and will automatically redirect me every time I get into the environment. It's going to change the directory into the project folder. So it's really useful. For example, if you want to change quickly from one project to the other, you can just type this, use another function that is included in the Virtualenv wrapper package, is work on. If you want to move from one environment to the other one, you can just use this work on M2. Boom, and you have there the environment activated, and we were redirected to the directory of the project that is defined in the environment. Make sense?
Yep.
And also a very useful thing that you have to keep in mind is the possibility of working with different versions of Python. So, for example, if I check this, locally I have Python 2.5, 2.6, 2.7, and 3.4, right? I have all these interpreters installed in the computer. But if I go, for example, if I want to work on the environment we have just created, and if I execute the Python REPL, you see here that I have the version, by default, I have the version 2.78, right? But what if I want to work in a project with Python 3? I can just deactivate this Virtualenv, and I can create a new Virtualenv called env3, and I can say -p. It means I'm going to specify which interpreter I want to use, and here I need to specify the path where the interpreter is located. So, for example, for that I can use this switch Python 3.4. Oh, yeah, there you have. This is the path where the interpreter is located. So what I can do is create a Virtualenv called env3 and use this interpreter, right? This is creating the new Virtualenv. We are in there, and now if I execute Python, you see here that now I'm using the Python 3 version instead of the 2.7. Make sense? Mm-hmm. So in the same computer, I'm running one project with Python 2, one project with Python 3, without any problem, and they are completely isolated. Do you see the importance of this topic?
Yeah.
Really, really useful. Please take a look. If you have some time, play with it. If you have any question, you can just ping me and ask me wherever you want. Okay? So, what else? What else? How are you guys? Are you burnt or tired?
Good.
We have covered a lot of things today.
I just got Virtualenv.
All right. Let me think about what we're doing. So, okay. Let's cover just one more small topic. Well, it's not small, but we're going to make a quick introduction. There is unit testing. Have you ever used unit testing in Python?
In the homework, yeah.
In the home. Oh, okay, perfect, perfect, pretty nice. So, sharing the screen again, and I have some slides here. This topic is super important. I mean, if I told you that some things I used to, I mean, I use some topics just a few times at work, and other one I use them every single day. This is one of the topics or things that I use every single day at work. We use testing a lot. Everyone uses testing a lot, or they should use testing a lot. And you need to be really familiar with this. This is one of the first things you're going to find in the hiring processes when you try to enter a company. For sure, they're going to ask you to write some code and also to include some unit testing. So let's make a quick introduction to it. This is the general goal of unit testing. It's basically a separated piece of code that is in charge of testing what some functionality should do or is actually doing, right? This unit test module, package that you see in here is a built-in package, and it's the official way of unit testing in Python. Basically, we have, in this case, we're creating a new test case. I'm sure you are already familiar with it. And every single function that you have inside class, the class that is inheriting from test case, is called a unit test.
Do you generally always put the unit test code where the same classes, like in the same file?
No. Usually we used to have a separate package called tests, and inside of course we have a of course you are going to have many tests, and you're not going to have all of them in the same module. So for that we create a new package special for test cases, and inside the package, there is a folder, we create different modules for from different conceptual topics, like test the models, test the API, test whatever you want. You create different modules, and you put your tests in the proper module depending on the concept, right?
Yeah.
Make sense?
Yeah, I just have to see the structure.
Yeah. So basically, you're going to have one single function starting with the word test underscore here. All the functions starting with this prefix is considered as a unit test, and it's going to be run for the test runner that you have here on the button, right? So basically what we are saying here is, if anyone is executing this module, execute the main function of unit test that basically is trying to find all the classes inheriting from test case and running every single test case inside. Make sense?
Yeah.
And we also have these two special methods. I don't know if you have ever seen the setup and tear down methods. Have you ever used them?
No.
They are really useful because sometimes you need to repeat some logic for every single unit test. And instead of writing the same lines in every single test, you can move the logic into the setup or tear down function. These two functions are executed before and after. I mean, the setup is executed before and the tear down after every single unit test. Do you follow me?
Yeah.
So, for example, if you have in the previous case, in this case, we have just one test case. If we also define the tear down and setup method, the execution order would be, first of all, the setup is going to be executed, then the test, and then the tears down. And the same for every single unit test you have defined there. Right? Did you get it? this is really useful, for example, when you want to define testing data, for example. If you want to test something, for that you need some testing data. You can define the data in setup, and you're going to have that data available in all the unit tests. Make sense?
Yeah.
All right. And for each single test case, you have, let me check if I can copy this link. We have different ways of testing things. Take a look at this. We can assert that something is equals to other thing. We can assert that it's not equal, that something is true, that it's false, and a lot of things that you have in here, they are special functions of the unit test library. So for example, if you want to test, you have a function sum, for example, and you want to test that if you send sum 1 and 2, the function is returning 3. You can store the result of the function in a variable, and you can set self.assert equal the result of the function 3. And basically this is going to do nothing if the result is expected, or rise and assert error if it's not equal. Make sense?
Yeah.
Okay. So let's go to Cloud9 and let's make a quick example of this. Unit testing.py. I think we have, no, correct. So I'm going to create a simple function, xsum, here that is receiving A and B again, and this is returning the sum of A and B. Okay, who wants to implement the test case for this? Anyone?
I can try.
All right. We need first of all to define a class that inherits from unittest.testCase, and then create a new test case that evaluates if the result of this function is expected or not. And finally, we'll add here if name is equals to main, then unittest.main. Remember that the class names are always with camel case, you know, with the, yeah, perfect. But actually, we shouldn't use this because this is a special name from the class we need to inherit from. You remember? It's unittest.testCase. Yeah, that is like the base class that we are inheriting from. Test case with camel case. Perfect, and let's just put my test case here, so we have a different name.
Yeah.
Assert with double S. And remember that you are inside the class, and this assert equal is an instance method. So you need to use the self dot. Wait.
Okay.
First of all, you need to define the function here, def, and the name of the unit test. Do you remember starting with test underscore?
Define.
For example, test underscore sum. Right. And as every single function or method inside a class, we need to send the self argument as yeah, right, perfect. So now inside the unit test we have the self object available, and we can use that to execute all the asserts we want. Perfect.
I think does it have to match the name of the original function? Shouldn't it be test mysum?
No. You don't need to match.
It doesn't have to match. Okay.
No. It's just like for to keep track of which function we are testing. But no, we can put there test A or test X or wherever you want.
Okay.
Okay.
Right. So looks good. I'm going to execute the code. Run. And do you see my screen? Here, run one test in 0 seconds. Everything is okay. Perfect. So everything is working. Now, let's see what happens if I remove this plus from here and I change it with an asterisk. So we are performing a multiply instead of a sum. The test should fail, of course, because now 2 multiplied by 3 should give us 6 instead of 5. And there you have assertion error. 6 is different to 5. Right?
Mm.
So this is a really useful way of checking if your code is behaving in the way you are expecting or not. So for example, if we want to test sum with negative values, for example. Right? I want to test what is happening when I send a negative value to the function. If I send, for example, 5, minus 2, what should we get here?
3.
3, right. So let's see if it is working. There you have, right? So I want to add one more thing here. It's very common to use test cases to define the interface or the expected behavior of your code. Sometimes instead of first writing your code and then implement the test case, we used to first implement the test cases just to define the interface and the way the code should behave, and then implement the code until all the test passes. Make sense?
Mm-hmm.
This is called, check my screen, this is called TDD, Test Driven Development. Have you ever heard about this?
Yeah.
It's not widely used, but I mean, I used to do this a lot. For example, when fixing bugs in the company. For example, if I find any bug in the code, I first of all write the test that fails because of that bug, and then I fix the bug in the code, and the same test should now pass instead of fail. And I end up with both the fix of the code and also the test case for this case. Make sense?
Mm-hmm.
All right, guys. I don't want to kill you anymore with so many topics. We covered like 5 topics. It was insane today. But do you have any particular question? As a general overview, we went through files, context managers, decorators. What else? Well, of course, unit testing, and nothing else, right? I think that's pretty much everything.
Virtual environments.
Virtual environment. Yeah, package, modules, virtual environment, virtual wrapper, a lot of things.
Yeah.
So we still have 10 minutes, but I think we're going to stop here because we are everyone kind of burnt. Let's just make a quick comments on the group assignments. So from now on until next Tuesday, you're supposed to be working on the file database, right?
Yep.
Do you want to keep the same groups or do you want to make new groups? As you want.
I'm fine with either way.
Considering you still have to join all the code you have from the offshore interprogramming battleship, you can use the same groups. So you can use the same meeting to also plan how you're going to work for the new one, right? The new group assignment.
Okay.
All right. So let's keep the same groups. I'm going to write Yatri sending the recorded video of this class and saying that you're going to keep the same groups for the next week. Okay?
Sounds good. Yep.
Okay, guys.
I wasn't here for the assignment. What is it going to be about? Because I know, I think I read about it, but I thought maybe you were going to clarify something.
Which assignments?
The group project.
Oh yeah, of course. So this week, from now on until next Tuesday, you are supposed to work in the file database.
Okay, file database. Okay.
And you are going to keep the same groups as before.
Okay.
So keep working on that, and if you have any comments or questions, you can just reach me in Slack whenever you want. I'm available most of the mornings in there. Okay?
No problem. Yeah.
Any other questions? Nothing? Perfect. So thank you, all of you guys, for attending. Nothing. See you next week.
All right. Thank you very much.
Bye, everyone.
Bye.
See you.
See ya.